Okay. Hi, everyone. Today, our coffee break will be held by Giuseppe Francesco Cesare Lama, postdoc researcher at University of Napoli Federico II at the Department of Civil and Environmental Engineering. In his career, Giuseppe earned a master's degree in environmental engineering and a PhD in agricultural sciences at the same university. He was then a visiting PhD student at the Aalto University in Finland, where he improved his knowledge on eco-hydraulics, and he was awarded with the best PhD thesis on forest hydraulics in 2020. Thanks, Giuseppe, for presenting your research today, and now the floor is yours.
Thank you very much for this chance. Hello, everybody. This presentation is focused on my PhD thesis, and now we are working with some of you that I already watched in the floor. In order to characterize the flow resistance of vegetated water bodies in both flume and real scale problems. In particular, we are going to understand more deeply some issues about the flow resistance in the vegetated water bodies colonized by real riparian vegetation. Is it clear? Can you see clearly my presentation, my slides?
Yes.
Okay. In situ ecohydraulic conditions for vegetated water bodies are of course characterized by different kind and configuration of riparian and riverine vegetation. Depending essentially on the submergence, we have emergent vegetation when the height of the vegetation is greater than the bankful water level. Then we have a floating vegetation that is developing at the bankful water level, and submerged vegetation when the vegetation height is lower than the water depth. There is another important distinction between vegetation in a real scale that is given by the biomechanical behavior of vegetation under the action of the water flowing. And we have rigid stems and flexible stems. The interaction between water flow and vegetation is extremely complex and important in real applications. In particular, we have that in natural conditions, natural water bodies in fully vegetated configuration can give a high environmental quality to the ecosystems that are growing inside the water body, but it is paid by a very low hydraulic efficiency in terms of conveyancing. So the classical approach of land managers and hydraulic engineers in these cases was the total vegetation removal from the water body, that of course has an improvement in terms of hydraulic efficiency of the entire channel, but with a very huge negative environmental impact for both aquatic and terrestrial habitats established within the water body. So the main question of my PhD thesis, but of ecohydraulics in general, is how to balance these two needs. So we had a study of the characterization of the hydrodynamic behavior of a real reclamation vegetated channel in Italy, colonized by the giant reed beds that are with riparian species that is widespread almost all over the world. And we had, in this case, measurements given by acoustic Doppler velocimeter that allows to measure the 3D components of velocity, so also a turbulence characterization of the main features of the flow. We were also involved in studying the impact of the uncertainty associated with the image processing of images acquired by drone in the estimation of the well-known leaf area index, that is a parameter extremely used in agriculture and forestry for characterizing the vegetation biomass. And its impact on the flow-resistant models of rigid vegetation, like the plants that we survived in the real vegetated channel. So we had real-scale hydrodynamic characterization of the vegetated channel in 3 vegetation scenarios. We have the full vegetation scenario that is associated with the natural conditions without any human intervention. Then we have a central cut of vegetation with 2 side buffers, zones of vegetation along the entire channel, and the total removal of vegetation. Of course, we needed to establish a steady flow conditions in the vegetated channel, and we were able to do it in some hours with a series of upstream and downstream pumps. So we have here the flow fields related to the velocity on the direction of the flow. So in this case, is the stream-wise velocity. So we have the full scale in the full vegetation scenario. We have very low vegetation, of course, and the vegetation and the velocity fields are not so predictable and not completely developed in the cross section. And we with those very low velocity, we already reached the bank full station. So with the central cut of vegetation, of course, all the stream was developing inside the central part of the vegetation as expected. But the most important thing is that the bank full level was not reached. So it is safer for flooding conditions, and it's a good balance also for the buffer zones for the growing of terrestrial and aquatic habitats. So in non-vegetation scenarios, we have, of course, a complete development of the velocity fields. We also studied the turbulence in terms of kinetic, turbulent kinetic energy, and this is a proxy of the oxygen production inside the water body that is extremely useful for benthic species, and of course for the environmental quality of the entire water body. In this case, we have a very, very low possibility of production of potential production of oxygen, because the turbulent kinetic energy is quite zero in this situation. Of course, in the case of central cut scenario, we were able to guarantee a very high agitation and potential oxygen production in the central part of the channel, and that is higher than in the case of no vegetation scenario. So in terms of flow resistant modeling, the most used and employed approach is based on the so-called rigid cylinder analogy. That is an analogy between real plants, rigid plants, and rigid cylinders, where the main parameters to be accounted for are, of course, the stem diameter, measured typically at 40 centimeters from the river bottom, then the plant height, of course, in average terms, because we are aware that we have, in real cases, we have no single plants. We have the so-called stands or patches of vegetation. So an average approach is the one that can be used properly in the rigid cylinder analogy. And then the so-called stem density, that is the number of stems for a unit surface area of the river bottom. My experience, of course, was based essentially in the use of leaf area index, that is defined as the total one-side leaf tissue area per unit land water. That is a definition extremely useful for both agricultural and forestry applications because it's a synthetic, unbiased parameter, the leaf area index, to account for the phenological stage of the vegetation. And in ecohydraulics, leaf area index is proportional to the streamwise velocity, that is proportional to the drag force, according to the so-called Järvelä model. That is a model that was under the study of Professor Järvelä of Aalto University. Typically, approaches for measuring leaf area index are based on indirect measurements of leaf area index. And in this case, we used an extremely accurate and rigorous optical device that is the so-called like or plant canopy analyzer that measures the attenuation of sky diffusive radiation through the canopy of plants or stands. That is essentially a difference between ratio between above and below canopy measurements. And it is extremely useful because we have the digital automatical live computing, but with extremely high time costs. So we wanted to understand the comparison between leaf area index obtained by plant canopy analyzer and multispectral images acquired by drones. Of course, the importance is based on the fact that we have multiple bands, so the image processing is extremely rigorous and quite no consuming costs, no time costs. Sorry. So on the right of this slide, we have an example of a leaf area index map based on the drone analysis, image processing, that is derived from direct measurements of the so-called NDVI, that is the normalized difference vegetation index. So in our cases, we have 200 points that are 200 stands. And we compare the so-called LICOR and drone-based leaf area index. And we have a very good level of correlation between the both parameters and very low bias. So we can assess from this study that so define drone-based imagery is a very valuable alternative to plant canopy analyzer LICOR in order to assess leaf area index of giant reed beds, of course, at reach or field scale. So at the end, we wanted to understand the study the sensitivity of the uncertainties of light drone leaf area index measurements on the outputs of the Yarvela model. In the range of values of LIFAR index based on drone that we obtained from our study, we were able to obtain a sensitivity or relative uncertainty connected to the uncertainty of LIFAR index that is at most pair to 10%. It is very very satisfactory as a result of finding, because it's the same range of uncertainty of the velocity obtained through the ADV themselves. So it's quite an important finding of this study. So, in order to conclude, in this case for this study, we can say that the hydraulic efficiency of vegetative reclamation channel obtained through the central cut scenario is highly comparable to that observable for the no vegetation scenario. We can also assess that the UAV-based imagery can be effectively used in order to assess the LIFAR index of rigid riparian stance, to be then employed in flow resistant models based on LIFAR index. And of course, there is a need for fertile field campaigns of measurement in order to analyze a wider range of riparian and riverine vegetation species in a larger spectrum, of course, of in situ ecohydraulic conditions in terms of both hydrodynamic and phenological stage of the development of vegetation. Thank you very much for your attention.
Thanks, Giuseppe. Now it's time for some questions. Are there any questions?
There is a question in the chat.
Yeah.
Oh, okay.
Oh, sorry.
Sorry.
Yeah, I will go. Thanks, Giuseppe, for your very nice presentation, and it was a pleasure for us to have you here. I've got a question about your method, which is very interesting indeed. And my question is it like directly applicable to other plant species, or do you see any additional bias that this methodology could have if we want to apply to other, like, I don't know, kind of plants?
Thank you very much for the question, because this is now a new open window of research, because of course LIFAR index methods were obtained in flume scale experiments. You know, the Yarvela method was obtained in flume experiments. So the main point is to understand in which conditions we want to apply the method. So a sensitivity analysis in this case in terms of different conditions, ecohydraulic conditions, can give us more indication about your question, because of course different kind of plants have different behavior with different values of velocity and or terms of flow rates. This is something that of course can be used in a wider range of possibilities, but in my opinion there is a lot of study to do to have a rigorous answer. Was it satisfactory, my answer?
Yeah, sure. I understand that. I mean, you need to further develop your research to give a complete answer. I mean, it's hard to develop something that works for everything. I totally understand.
Of course, Professor Yarvela group, of course, had a lot of new studies, but just a few in rich scale conditions. And this is extremely challenging, but it's something that with the, in my opinion, with the drone techniques and technologies can be simple to achieve.
Thanks very much.
Thank you. Other questions?
Una in chat, Fra.
Yeah, from the chat, a question from Luis. Are your results useful for validating CFD simulations of vegetated streams?
Thank you for the question. This is something extremely interesting too. And I think that the first, I mean, you need very accurate measurements in order to validate every CFD model. This is something that is general, in my opinion. So the best thing is to go deep into the understanding of experimental studies and analysis, and then you can, of course, model the behavior of the fluid dynamic behavior of vegetated water flows. But it's important to have a clear and complete understanding of the field scale measurements. This is the main point, in my opinion, because of course CFD is growing in a lot of models for turbulence and for any kind of hydrodynamic problem. But when you interact with the living material as plants, it's important to have a lot of experiments in many ecohydraulic conditions, different ecohydraulic conditions. So you can have a data set that can validate correctly any model.
Thanks. Lorenzo, if you want to.
Yeah,
ask
thank you for the presentation, Giuseppe. I have a question for you about one of your conclusion. My question is about the first of your conclusion. You said that you obtained comparable results for the vegetated channel and the central cut. I was thinking about comparable results in terms of what?
Thank
Can
you very
you
much.
maybe explain a bit?
Thank you very much for the question. No, not same results in absolute terms, but it's more like in terms of effect on water quality and hydraulic conveyance. Sorry, because we were able to, in my opinion, we were able to achieve a good balance between the need for improving the hydraulic efficiency of the water channel, of course, in terms of velocity and lower water level with respect to the fully vegetated condition, and also the buffer, the two-side buffer vegetated parts of the cross section can be useful for the development and the restoring of the aquatic habitat and also the terrestrial habitat, because we performed these studies in the, you are from Tuscany, so you know that the Massaciucoli National Park, and then there are a lot of bird species that grow and developed in the channels. So this was the aim of the study, to obtain a balance, of course, in qualitative and quantitative ways, between the two needs that are, in our opinion, the main purposes of in situ ecohydraulics. I was convinced that this study was a good first example of ecohydraulic application in real agricultural areas. Is it clearly now?
Yes, thank you.
Thank you.
Okay, there is another question from the chat from Diego. He observed that the velocities are quite low and asks if the conclusions apply to also for supercritical flows.
This is maybe in supercritical flows, the conditions are very different. And in supercritical flows, this is my opinion at this moment. Also, the habitats inside the rivers are different. I mean, in this case, maybe there is a totally different yes, ecosystem and environment inside the vegetated water body. This is a study that we performed at low velocities because the vegetated reclamation channels experience very low velocity regimes. So this is a very interesting question, but of course, in my opinion, it's a totally different configuration in both terms of hydrodynamics and environmental issues. I don't know if you agree with this answer, but I think that it's totally different, the approach. And it's something new, of course. It's something that can be studied more in detail with real scale experiments. So okay. I think that my range of velocities is more suitable for reclamation channels.
Okay. Are there other questions? If there aren't, I think that we can finish with our coffee break. I remember that next coffee break will be held by Giulia Evangelista, PhD student at Politecnico di Torino, on Tuesday, 20 of June. And she will talk about climatic and morphological factors that influence flood attenuation of Italian dams. So, thanks, Giuseppe, for the presentation. Thanks, everyone, for joining us. And let's see in the next coffee break. Thanks.
Thank you all.
Thank you very much.
Ciao, ciao.
Ciao.
Ciao, ciao.